Hello everyone, my name is Arman and we are going to do Math 113, Calculus 1 for science this semester. So this is basically a differential calculus course with applications in science. So calculus basically and the concepts in calculus such as limits, derivatives, and integrals, I can say they are used or can appear pretty much everywhere in almost all fields, from physics to other science majors, or engineering or biology or economics, genetics. So anywhere, or other fields of mathematics, anywhere you go, you can see that the concepts of calculus can appear there. Now, in this course, differential calculus will focus on limits and derivatives. And integration basically is the main topic of calculus 2. So in the course, we'll start with the limits and the concepts and how to compute limits of a function. So I assume that you are familiar with the concept of functions from pre-calculus or from high school. And then we will look at derivatives as a special case of limits. And again, we'll see the definition of a derivative, definition of the derivative of a function, and also how to compute first order or second order derivatives of a function. And we will also see the applications of derivatives. So like I said, applications can appear in pretty much any field, but we will focus on science, application science, and namely in physics, and also optimization problems. So optimization problem is also very important in, again, all fields. Let's say if you want to maximize or minimize something, it could be maximizing a profit or your income, or maximizing, let's say, area of it. Let's say if you want to create a fence, for example, on a farm, for example, let's say, or minimize time of doing something, right? So you probably prefer to, if you want to perform a task, you prefer to do it in a shorter time, right? So optimization is very important in, again, many fields. So one way to do optimization is using calculus and derivatives. So we'll look at that concept, and also the concept of, let's say, sketching the graph of a function. So, you saw the concept of graph of a function, and you learned how to sketch a graph of some simple functions in pre-calculus. But you will see that for sketching graphs of more complicated functions, we need derivatives. And we will do that in this course. So let me go over the course outline. I've uploaded the course outline on Moodle. Hopefully you have seen it already. But let's also go over it quickly. I'm going to share my screen. Okay, so yeah, the lectures will be uploaded on my YouTube channel by end of Wednesday and Saturday each week. And then office hours on Monday, Thursday, 8:30 to 10:30. And prerequisite is pre-calculus, because we'll deal with the concepts you learned in pre-calculus, such as functions, inverse functions, trigonometry, exponential functions. So we need all those concepts in this course. So that's why pre-calculus is a prerequisite for this course. And the textbooks, so there is a main textbook and also supplementary textbook. Both of them You can download them for free. They're basically open sources, so you can download them for free. And then if you want to look at the course schedule or the contents, so basically, like I said, we will spend a few weeks for limits, the concept of limit of a function and how to compute a limit of a function. And then we'll look at derivatives for a few weeks. Again, when I say we look at derivatives, first we need to know what the derivative is or how it is defined. And we also need to know how it can be computed. So basically, and also the properties of derivatives. So such as mean value theorem, we'll see, and other important theorems. And then for a few weeks, we'll look at applications of derivatives. Like I said, it could be in physics, could be optimization. So velocity, acceleration, in physics, as you can guess, or approximating a function near a point. Well, you may say, okay, why do we need to approximate a function? So there are different reasons, So one simple reason is that we can approximate a function without calculator. Let's say if you want to find ln of something, or e to some power, let's say, normally use calculator, right? But let's say if you want to give some approximation without calculator, we'll learn how to do it in this course. And also you'll see that another advantage is that later, especially in calculus 2, you will see that you can generalize those concepts of approximations or linear approximations to find the exact value of a function using a series, which is like a generalization of a polynomial. So those approximations could become, exact values as well later by adding some terms. And then, like I said, I will also look at the concept of sketching graphs and how to sketch, or the steps that we need to sketch a graph of a function. And for that, we will need derivatives and finding zeros of derivatives, determining the sign, whether positive, negative, etc. And for evaluation criteria, so we will have 3 tests. So I wrote the proposed dates and times here. And if these dates and times do not work for you, please let me know by Thursday, so basically tomorrow, and let me know why they don't work for you, or which time, or how it can be changed so that they can work for you. And so I wrote here about the tests instructions. So I strongly suggest that you go over these instructions very carefully. But let me tell you the idea. The idea is that all the tests will be closed book. Sometimes you may, be allowed to have one page formula sheet, but it depends on the test. So I will let you know before the test whether you're allowed to have that one page or no. But other than that, the exams are closed book, meaning that you are not allowed to use any notes or books or electronic devices such as laptops, cell phones, tablets, etc. And so the way that we are going to conduct the test is that, I'm going to read the questions out loud for you. So that takes around usually 10, 15 minutes in the beginning of the class. And then during that time, that when I read the questions out loud to you, you're allowed to look at the screen to make sure you copy the questions correctly. And after you copy the questions, then you are not allowed to look at the screen or your books or anything. And you just need to look at your own paper until the end of the test. Usually the midterms are around 1.5 hours. You have 1.5 hours to write your solutions. And then at the end of that 1.5 hour, you'll be asked to, take pictures of your solutions and scan them with CAM scanner or similar app, and then upload it on a Moodle as one PDF file. So you have to convert them into a single PDF file and then upload that on Moodle. So this whole process will be 2 hours. So first, and another important thing for the test is that how you set up your webcams. So the way that you set up your webcam is very important because the exams are online, and that's the only way that I can invigilate the test. So it's important that you set up the webcam so that your face, your hands, your surrounding, your papers, and the surface in front of you. Let's say you're allowed to sit anywhere. Let's say if you're sitting on the floor, the surface of the floor has to be visible. If you're sitting on a bed, the surface of the bed has to be visible, and so on. So usually, like I said, 15, 20 minutes for checking the webcams and reading the questions for you, and then you have 1.5 hours to write your test. And then around 10 minutes at the end of the test, you have time to scan your exam and upload it on Moodle. So this is basically the idea, but please go over the instructions more carefully. And I will also send some sample pictures about how to set up the webcams before each test. Or before test 1, basically. I will send you the sample pictures and then you can use them for the other tests as well. And for homework, there will be 2 types of homework, one in web work. So some people ask, that they haven't been able to log in yet. That's true because I haven't created your account yet as there is still no assignment uploaded. But I will do that by end of this weekend. And then you can use your student ID as username and password to log in. And then, of course, you can change or it's better to change your password after you log into something else. And yeah, so that's the web work part of the assignments, which worth 7% of the final term grade. So 7% will be web work. And there will be another type of homework, which is called additional assignments, which I upload on Moodle. Because, in web work, it's mostly computational questions. So if there are some conceptual questions or some proof type questions, I cannot upload them on web work. So I have to upload them as a PDF file on Moodle. So yeah, please go over them as well. But you don't have to hand in those additional assignments. Just do them for your own and for your practice and to get prepared for the tests. So most questions in the tests are similar either to lecture notes or these additional assignments or web work questions. So most questions in the test are similar to one of these 3 sources, lecture notes or additional assignments or web work questions. And if you miss an exam, you'll get 0 for it unless you submit a doctor note within 1 week after the test. And here are the information about or instructions about accessing web work. But please, like I said, wait until end of this weekend so that I create the accounts for you, and then you can access the first homework. And these are, classroom code of conduct, which is common for all college courses, and cheating, plagiarism policy also, again, common in all college courses. And the grading system, I'm sure you're familiar with it. Yeah, and that's all about the course outline. Now let's get started with the materials we want to do today. So I'm going to stop share here. All right. So the first chapter we want to start with, chapter 1, is about limits. So before we start limits, I want to remind you about the concept you learned in pre-calculus, maybe the most important concept you learned in pre-calculus, which was about functions. So in pre-calculus, we saw about functions. So what was a function? Well, a function was a rule, right, that assigns exactly one output to each input. So each function basically is like a machine. Each machine has inputs and outputs, and functions also are machines that have inputs and outputs. So we can, so this one we can say it's a rule that assigns exactly one output to each input, right? So we can imagine a machine here. This is F, this is input. Normally the input, as you know, is denoted with a letter like X or T, and you apply your function to your input, and then the output will become a number. Let's say you can call it F of X. So if the input is X, the output is F of X. So for example, let's say F of X equals, let's say 2X plus 1. Or we could say F of X equals X squared. So when you say F of X equals X squared, means if your input is X, the output is the same as input, but input to power 2. You have to raise the input to power 2 to get your output. And then you know that each function has a domain and range. So what was domain and range? Divide this into 2 parts. So domain of a function, let's say F. The notation is normally df, and it's the set of all inputs and range of a function. Range of a function f. Normally the notation is rf. This is the set of all outputs. And another notation that is normally used is if you use the notation f from, let's say, A to B, like this. So this one, A here, A here is domain, and B here is called codomain. What is the meaning of codomain? Means a set containing the range. A set containing the range. It could be the range itself or something bigger than the range. And in that case, this is called a codomain. So this is the notation. We say F from A to B. So for example, let's say if you look at, let's say, F from the set 1 to 4 to R, F of X equals X squared, then we can say that the domain of F is just a set with only these 3 elements, 1 to 4, and range of F is the set 1, 4, 16. So codomain is a set of all real numbers, which is a set containing the range. Range is a set of all outputs, which is 1, 4, and 16. The domain is 1, 2, and 4. So this set is domain. This set is codomain, which could be the range or something bigger. In this case, it is something bigger because range is only a set containing only these 3 elements, but codomain is the set of all real numbers. Okay, and then another important concept to learn in pre-calculus is a graph, the graph of a function. Graphs and interpreting graphs is extremely important, both in pre-calculus and also calculus 1, and also calculus 2, and many other courses. The graph of a function f so this is the set of all pairs of the form x and f of x, where x comes from the domain. So the set of all pairs x and f of x is called the graph of a function. You know that normally to sketch a graph of a function, we need 2 axes called x-axis and y-axis. And the x values here denote the inputs, y values denote the outputs. And if you want to sketch a graph of a function, you need to find all the points or all the pairs of the form x and f of x. And if you find all such points, then that is called the graph of a function. So for example, let's say the example we saw, if you remember, it was f from 1 to 4 to r, f of x equals x squared. So in this case, if you look at all the pairs of this form, because we have only 3 elements in the domain, so the graph of the function consists of only 3 pairs. So 1 and f of 1, 2 and f of 2, and 4 and f of 4, because the domain contains of only 1, 2, and 4. So 1 and f of 1, 2 and f of 2, 4 and f of 4. So if I find all such points, so 1 and f of 1, let's say, one and f of 1, 2 and f of 2, and 4 and f of 4. So, but only these 3 points I have to, so this is the graph of x squared for the positive x values, but I don't need the whole graph. I just need 3 points of it, because this function f is not f of x equals x squared with the whole domain of real numbers or even positive numbers. The domain of this function is only 3 points. So the graph of this function consists of only 3 points as well. Which 3 points? Only these 3 points. So I have to delete the rest of the graph and keep only these 3 points. Okay, this is 1 and f of 1, which is 1, 2 and f of 2, which is 4, and 4 and f of 4, which is 16. One and 1, 2 and 4, 4 and 16. So as we said, the graph consists 3 points only in this example. Okay. Or another example, let's say the graph of or sketch the graph of f of x equals 2x plus 1. So what should I consider as the domain here? See, here the domain was mentioned as 1 and 2 and 4, but here the domain has not been mentioned. So what should I consider as the domain if the domain is not mentioned? So note, if the domain has not been specified, consider the largest possible domain for which the function is not undefined such domain is called the natural domain. So how do you find the natural domain of a function? Natural domain means the set of all points for which the function is not undefined. So the function, you know, it could be undefined if there is a denominator, for example. If there is a denominator and denominator is 0, the function could be undefined. Or if there is a square root under the square root, if it's negative, the function will be undefined, right? So to find the natural domain, you just need to look at the expression of your function. If there is a denominator, make sure denominator is not 0. If it's a square root, make sure under the expression under square root is bigger than or equal to 0. And also if there's logarithm, for example, expression inside logarithm has to be positive, and so on. But for polynomials, where there is no denominator dependent on x or no square root, etc., the domain or the natural domain is the set of all real numbers. And this is a linear function, it's a straight line. The graph is a straight line. It's of course a polynomial. And like I said, for all polynomials, the natural domain is the set of all real numbers. So we can mention here that for polynomials, natural domain, the natural domain is equal to a set of all real numbers. So here we wanted to sketch a graph of this function, 2x plus 1. So the natural domain set of all real numbers, and the graph is a straight line. And how can we sketch the graph? Well, it's a straight line. We just need 2 points of it, right? So let's say if x equals 0, y is equal to 1. If x equals 1, y is equal to 3. So 0 and 1 is here. And then 1 and 3 is here. And then I just need to connect these 2 points together. And there you are. This is y equals 2x plus 1. Okay, so this is the concept of the graph of a function